Students using an AC generator. So an AC generator, another word for that we've said before is an alternator. Alternator. With a coil, and they rotate it at a steady speed in a uniform magnetic field. So the coil rotating in a magnetic field produces electricity, and this produces a sinusoidal. Sinusoidal, remember, means a sine wave shape. Voltage signal that varies with time like this. Calculate the frequency of the AC signal. Calculate the frequency of this as shown in the figure above. So there's a couple of formulas for frequency. The one that's helpful for us at the moment is frequency equals 1 over the time period. And the time period equals the time for a complete rotation. In this case, one full rotation ends here at 100 milliseconds. So our time for this at the moment is 100 milliseconds. We need to put that into seconds. Now for those of you good at their mental arithmetic, that's 0.1 seconds. But if you're not sure how to do it, 100 milliseconds, and to get into seconds, because it's milli, it's 1,000 millis in 1. So you have to divide by 1,000. So 100 divided by 1,000, 0.1 seconds. So into this formula, divide by 0.1, and that equals 10 hertz. That's 10 cycles per second. Cycles per second. Okay. Calculate the RMS voltage of the signal as shown in figure 5. So because this is an AC signal, the top value it goes to, that's the peak voltage, and that's 20 volts. So we've got the peak voltage is 20 volts, and to get the RMS, we need to take the peak voltage and we need to divide it by the square root of 2. 20 over root 2, and that equals 14.1 volts. Alright, let me just open up the last question. Alright. The students now halve the speed of the rotation, so they're going slower with their rotation of the device, of the AC alternator. On the axis below, sketch the voltage signal that the AC generator will now produce. So before we had it going up in one cycle to 100, 2 cycles to 200 milliseconds. So they're not going as fast now. So one cycle will be completely done by 200 milliseconds. That's a nice sine wave. It's a pretty crappy sine wave. Alright, now if you remember the AC generator that we had in our class, whenever we wound the handle faster, not only did the light flicker faster, but it also got brighter. So if we wind it slower and half the speed, the voltage is not going to be as high. The light, if it was connected to a light, the light wouldn't be as bright. So before we had 20 volts, this is half as fast. So this will be 10 volts on this side, and it will go down to minus 10 volts on this side.